Hi, Year 11. Today we're going to have a look at the unit circle. You remember that from last year. So the unit circle is on our x and y Cartesian plane, x and y, and just a circle of radius 1 that's spun around. We've got on the corners here where our radius hits the x-axis and the y-axis. So it hits there at 1, 0, 0, 1, minus 1, 0, and 0, minus 1. What we want to have a look at first is what happens in that first quadrant. And our first quadrant is between 0 degrees and 90 degrees. And that's what we're very familiar with at the moment because we've been doing right-angled trig. And in our triangles, our angles are all going to be, apart from our right angle, are all going to be less than 90. So that's where we've been concentrating on lately. So in our unit circle, we have a radius of 1. We can make a triangle out of that radius. We've got an x-coordinate and a y-coordinate. We've actually moved our point, actually I haven't talked about our point yet. We've actually drawn a point there. Our radius of 1 is drawn on there at some point x and y, and it actually has moved through an angle of theta. So we've moved up an angle of theta. So we can work out what sine, cos, and tan of that angle is in that first quadrant using that triangle. Sine of theta is opposite on hypotenuse, so sine of theta is y over 1, which is equal to y. Cos of theta is adjacent on hypotenuse, x over 1, which is just x. And we can also work out tan of theta, opposite on adjacent, which is y over x. And we've written all those down over here. The other thing we can have a look at, y over x, we can also think of that, if we go back to the sine and cos, y is also sine theta, and x is also cos theta. So that's where our sine theta over cos theta equals tan theta. So that's in our first quadrant. So the first quadrant is fairly straightforward. So what we can see from our first quadrant is that sine theta is positive, cos theta is positive also, and tan theta is positive also. So what we say is all of those three trig ratios are positive in that first quadrant. Let's go down to the second quadrant. So our second quadrant lies between 90 degrees and 180 degrees. And what we're going to think of as happening is we've still got our point P here, which matches our point from our first quadrant, but we're going to be thinking of that line or that triangle being flipped over and having been reflected in our y-axis so that it now sits in the second quadrant. Now we still have our y value. We now have a negative x value, so that changes it a little bit. But what actually has really happened is, although we're referring to this angle theta, what's actually happened is we've moved around through an angle of 180 degrees minus that theta. We're going to work out some rules to see how we can make the calculations a little bit easier so we can refer to theta instead of 180 degrees minus theta. And that's what we're going to do in this quadrant. Now, this is a right angled triangle, so we can have a look at sine, cosine, and tan again. So sine of theta in this quadrant is still opposite on hypotenuse. Oops, now hypotenuse is still a radius of 1, so it's still y over 1, which is still y, which is positive still. Okay, so that's like the first quadrant. So sine is positive here. Let's have a look at cos. Cos of theta is adjacent on hypotenuse, which is minus x over 1, which is minus x. So cos is actually negative in this quadrant. That's very interesting. And our last one is tan. Tan is opposite over adjacent, y on minus x. And again, tan is also negative. So sine is positive, and cos and tan are going to be negative. So I'm going to put a little sign being positive there. So all our things were positive in the first quadrant, and only sine is in the second quadrant. Now, let's just move over a little bit and have a look at how we can understand the relationship between our theta and our 180 degrees minus our theta, and try and make it a little bit easier for us. I'm going to change coloured pens for us now. Now, let's think, for example, what would happen if we had sine of 30 degrees? and we had its matching angle in the second quadrant. So our first quadrant, 30 degrees, would be here. In our second quadrant, our 30 degrees would be here, but it actually would be matched up with sine of 180 minus 30, which is sine of 150 degrees. Now, in our first quadrant, sine of 30 degrees is equal to a positive value. In our second quadrant, our sine of 150 degrees is also equal to a positive value. So we can say that those are going to actually be the same. So sine of 30 is going to be equal to sine of 150 degrees. What about cos though? Cos of 30 in our first quadrant is going to be a positive value because all of our trig ratios were positive in the first one. But let's have a look in our second quadrant. Cos of 30 in our second quadrant would be cos of 180 minus 30, which would be cos of 150 degrees. Now, cos of 150 degrees is going to actually be equal to a negative value, and it's going to be equal to negative cos of 30. Oops, a bit of a mess in there. So the value for cos 30 will be the same, except in the second quadrant, cos of that will be negative instead of positive. Okay, so let's go back and just have a look at what's actually happening here. Let's scroll across. So what's actually happening here in our second quadrant? We've moved through an angle of 180 degrees minus theta, but what we've worked out are some rules of looking at whether our sine, cos, or tan are positive or negative in that quadrant so that we can actually use theta to calculate with instead of 180 degrees minus theta. Let's go and move to the third quadrant now. Okay, so we've moved down here into our third quadrant. X, we've got a Y. So we are now between 180 degrees and 270 degrees. So we've moved through the first quadrant, we've had a theta there, we've had a theta here. What we're going to think of now is the theta from before. We're going to reflect down over the x-axis and have our theta shown in the third quadrant. But what we've actually really done is, if I grab another colour pen to show you a little bit better, we've actually really moved through an angle of 180 degrees plus theta. We want to see what we can learn rule-wise so that we can use the theta in the third quadrant to make our calculations a little bit easier. So using the same ideas as we had before, we're going to have a y value that now is a negative y value because we're down into the negatives for the y's. Our x's are still negative x's, and our radius of our circle is still 1 because it's still a unit circle. Let's have a look at what we've got. Okay, so sine of our theta in the third quadrant is going to be equal to opposite on adjacent, so minus y on 1, which is minus y. So sine is going to be negative in this quadrant. Our cos of our theta is going to be minus x over 1, which is minus x. So cos is also negative. Tan, however, of theta is opposite on adjacent, which is minus y on minus x. And our two minuses give us a positive. So tan is positive in this quadrant. So we've had all positive in the first quadrant, only sine positive in the second quadrant. And we've got tan positive in this quadrant. Oops. So let's just have a look at an example of what would happen. So an angle that would fit in that third quadrant would be, for example, 200 degrees. So if we had sine of 200 degrees, which is relating to our 180 degrees plus theta, so that's going to be equal to the same as sine of 20 degrees, but sine in that quadrant, this third quadrant, is a negative. So sine of 200 is going to be the same as minus sine of 20. So the values for sine of 200 and sine of 20 would be the same, but in this case, we would have a negative version of that. Cos of 200 is going to be equal to minus cos of 20 and tan of 200 in this quadrant, because tan is positive, would be equal to tan 20. They would be identical. Okay, so again, let's have a look at what we've actually learned in that third quadrant. We've learned that sine of our theta is going to be negative, cos is negative, and tan is going to be positive. Although we've moved to an angle of 180 plus theta, we've found some rules that we can use so that we can calculate using just theta. Let's jump over into the fourth quadrant. Similar idea as before. So now I'm thinking of my original point P and triangle being reflected around the x-axis from the first quadrant into the fourth quadrant. And although I have moved a whole distance of 360 minus theta, I'm going to look for the rules that I can use so that my calculations just deal with theta. So again, using our SOHCAHTOA rules in this final triangle, I find that sine of theta is minus y, so that's a negative value. Cos of theta is x, which is positive, and tan of theta is going to be also negative. So in our fourth quadrant, what we're finding that the only positive trig ratio we have is cos. Okay, so let's summarize what we've learned so far. We call it the Astc rule, or the all stations to central rule. That's how I remember it. All stations to central. That rule tells us what trig ratios are positive in each of the quadrants. So in our first quadrant, all are positive. In our second quadrant, only sine is positive. In our third quadrant, only tan is positive. And in our last quadrant, only cos is positive. So if you can remember all stations to central, that will help you out really quite a lot. Okay, now let's have a look and see if we can figure out some examples. Part 1 here says find the quadrants where cos is positive. Now, if we go back and have a look at our all stations to central here, cos is positive in the first quadrant and cos is positive in the fourth quadrant. Oops. Okay, part B, sine less than 0, or sine is negative. Sine is going to be negative in the third quadrant here, and sine is negative also in the fourth quadrant. So we've got third. Okay. For C, we're looking at where sine is positive and where tan is negative. So we go back and have a look at our diagram. Sine is positive in our second and our first quadrant, and tan is negative in our only the second quadrant out of those two. So the only one we can have a look at there is the second quadrant. Now let's find some exact values of our numbers here. Okay, so we want to find exact values. So tan 15. Tan 15 is in our first quadrant. In our first quadrant, tan is positive. I'm just going to change that a little bit because that had a little bit of a mistake in that. Tan shouldn't be of 15, it should be tan of 150 because we want an exact value. So tan of 150 will sit us in, go back over to here, the second quadrant up there. So we're in the second quadrant, tan is negative there. So that would be equal to negative tan of 30 degrees because it's 180 minus 150, which would be 30 degrees. Now we've got special triangles that we can look at for there. So it's going to be minus and tan of 30. So let's have a look at the special triangles. So I've just drawn that exact value triangle there. Tan of 30, opposite and adjacent is 1 on root 3. So we've got minus 1 on root 3 as our answer. Okay, the next one we've got is tan of minus 45. And minus 45 is going to take us backwards down here and look at 45 degrees into the fourth quadrant. In that quadrant, tan is going to be negative. So tan of minus 45 is going to be minus tan of 45. And if we go back and look at our other exact value triangle, what we'll get is minus 1, because tan of 45 opposite and adjacent is equal to 1. Okay, second last, sine of 225s in the third quadrant, that would equal minus sine of 45, and we pop that into the exact value triangles, we'd get minus 1 on root 2. We'll leave the last one for class to do.